Hi, thank you. Now I'm me and not Artem anymore. So today I'm talking about Lustre 216 and upcoming features and development. And so, as Peter said, the 215 release was made in June, I think. And so we're well underway in the 2.16 development. James, who's here, is busy working with the IPv6, and that's also sort of co-developed with Neil Brown in SUSE. And we also have another feature, optimized directory traversal. It's improvement of stat ahead. And I'll be going into some details on some of these. 2.17 is a new feature, quite interesting, is client-side data compression. And in some regards, we hope that it'll be very similar, reusing some of the functionality that was added for client-side data encryption. But it's been a project that's been underway for quite a number of years. Started several years ago at the University of Hamburg, and now we have somebody developing it at WAM Cloud to finish off that work. As well, there's well underway for metadata write-back cache. And we have some early discussion of features. Erasure coding is something that had again started quite a number of years ago with a prototype, and Oak Ridge is taking over the development of that feature as well. We're talking if we can start implementing some components of a Lustre metadata redundancy to allow reliability for MDTs. So on the LNet side, in 2.15, one of the features that landed that was quite interesting, worth mentioning here, is multiple connections, multiple TCP sockets for Ethernet. And so we found with high-speed Ethernet, 100 gigabit and faster, that we weren't able to saturate the network links with just one connection, and that's because of the high CPU usage for TCP connections. And so by having multiple connections per peer, we can have the connections working on different CPU cores, and that's significantly improved the throughput on TCP connections from a single client. And we have a heuristic that's relatively good in terms of auto-selecting the number of connections. You can always specify this manually if you want, but the default that we pick for 100 gigabit is 4 connections per peer, and that seems to be reasonable. And with increasing number of connections, if you have a huge number of clients or connecting to one OSS, for instance, it's potential that you could run out of TCP sockets. But, I don't think that there's people that are running, 15 or 16,000 TCP clients in one network without routing or anything. So it's probably going to be okay, but you can tune this manually. Another feature, LNet selection policy, also called UDSP, allows you to specify rules. So if you have dissimilar networks that you want to use with bonding, but you want to prefer one network over the other for some reason. So if you have, let's say, InfiniBand plus Ethernet going into one host, you can say, route all of the traffic over the InfiniBand if it's available. But if the InfiniBand fails, then fall back to Ethernet. Or you can select, if you have routing, select one interface over another for connecting. In 2.16, like I was saying, IPv6 support is probably one of the biggest features. And that's something that we've been wanting to do for quite a number of years. Neil Brown had started that development before the 2.15 feature freeze, and we'd started some of the infrastructure work to land in 2.15. But the majority of the functionality is going into 2.16. And so this is the work for implementing the LNet layer support is, I would say it's largely done. It's not quite all landed, but the code is there for LNet. There needs to be some more development done up at the Lustre level in terms of configuration logs and tools and things like that that handle NIDs, so that they can parse and print out IPv6 NIDs, as well as the configuration logs have records that some of them are fixed size that hold a NID in them, and in terms of doing routing between IPv6 and non-IPv6 clients, there has to be some compatibility work done there. And as well, there's an ongoing effort by mostly Chris Horn at HPE, doing a lot of work improving reliability of multi-rail peer discovery and health to improve corner cases in that functionality, steady series of patches. As well, like I mentioned, the dynamic server node addressing, right, to be able to handle clients with DHCP or servers without, with the server, you want to change it to a different network. Right now you have to rerun the configuration. It's a little bit cumbersome, but we want to be able to dynamically address interfaces on a server. So if you add new interfaces, then the clients would be notified transparently, and instead of having to rewrite the configuration each time. In terms of work on the client side, there's been some interesting new features. The GPU Direct for NVIDIA GPUs, and so we can do RDMA directly into GPU memory, and so that it improves the performance somewhat, not dramatically, but the big win with GPU Direct is it avoids CPU consumption, because you're not running over the inter-CPU links to route your data, and you don't use CPU cycles processing every byte. The drawback is that right now, if you're using GPU Direct, you can't do data checksums, because we compute the checksums on the client, and you wouldn't be able to do encryption and things like that that involve the CPU. But for most workloads, that's fine. As well, a number of performance improvements in terms of direct I/O and client-side encryption, which Sebastian's already talked about. Another little handy feature that Oak Ridge did is LFS find minus printf, and so then you can have it print out specific fields from a file. If you're looking, you do LFS find to find a bunch of files. You can say, oh, print me the size and the stripe count and the project ID or something like that, and instead of just printing out the name, right? And going forward with 2.16, one of the things that James said he would do is improving the O2IB to be more acceptable to upstream kernel developers, because we're using the OFED, in-kernel OFED, in a way that they don't like it. So that needs some cleanup. Encrypted file, backup, restore, Sebastian's already talked about. Buffered I/O performance, was in flight. And just, general cleanups in the client code. One day we hope it will be again submitted into the upstream kernel. It's not a huge priority for us, but it would definitely make it Lustre more available for ease of use for various users. And we have such the number of features going into Lustre is not growing by leaps and bounds, and we have good protocol compatibility. So even if the upstream kernel isn't getting all of the latest features, we do have fairly good compatibility in that front. On the back-end server side, there's also quite a bit of work being done. As I mentioned, MBALEC improvements On the ZFS side, the D-RAID feature that we developed at Intel, was finished off with help from HPE and Lawrence Livermore and is included in the ZFS 2.1 release. And that's the default. ZFS 2.1 is the default for 2.15 and going forward. Also, I mentioned a bit under the MBALEC presentation that OST sizes are growing, not just because individual disks are growing, but because of a declustered RAID. You want to have more and more disks in a declustered RAID group, and so it's essentially the size is growing kind of exponentially. The individual disk sizes are growing, and in order to keep the rebuild time constant, you have to increase the number of drives in a declustered RAID group, and combining that, is sort of exponentially growing the size. So we're, targeting 1 petabyte OSTs, but it's, entirely likely that we will need to have, 2 petabyte OSTs in a year or two. So with that, the large OST sizes is that we'll have, billions of objects per OST, and the on-disk data structures are not really suitable for that today. We have 32 subdirectories per MDT, and while that's acceptable, it gives us about 300 million-ish objects per directory tree. That's still quite a lot for one directory. And having a wider fan out, having 64 or 128 or whatever object directories doesn't really help, because you're doing random I/O within the blocks of those directories, and so you're not getting any efficiency. So rather than keep on scaling the number of directories, we're actually going to move it to having more directory trees, so that each MDT will create at most 32 million objects in one directory hierarchy, and then move to a completely new hierarchy. And so the old directories will stop being used, and you'll get a whole new set of directories. And so that is more efficient over time, because the old directories will fall out of cache typically, because you're not using them as frequently, and we can still have aggregation of creates in the new directories, and so it's more efficient. And this needs a little bit of a protocol change, but that work is underway. Other improvements for LDiskFS with trim on flash devices, and the parallel FSCK, I'm not totally sure we have somebody working on that anymore, but Pass 1 was, we did parallelization last year, and so, like Amdahl's law is, we've parallelized one part of it, now we're serialized on the next phase, and it's become the longest part of the work. On the MDS side, the biggest improvement in 2.15 was space balancing, and I think that that's a really important one. It makes D&E with multiple MDTs much more usable, because we're automatically balancing across multiple MDTs. And, we have customers now with 40 MDTs, and they do, multi-millions of operations per second, and they don't have to do any manual tuning there. Migration improvements on 2.16. We're trying to make the migration more robust, and we had to redo the hash function. There was a bug in the hash function, but because it's part of the protocol, we can't just fix the hash function. We have to make a new version, and so now we need clients and servers to understand the new hash. We'll backport it to 2.15, but it will be a while again before we can enable it by default. And just improvements in locking and things to improve performance with distributed transactions, because in 2.15 now that we're doing more remote directories, we want the performance of the remote directory create to be better. Currently it's about 1/10 of the speed of a local directory create, and we're going to try and optimize that further. One of the new interesting features, a metadata write-back cache. The development, it's a very large project, and so we're trying to get some parts of that feature to be included in an earlier release. And so we've carved out part of it. It's the batched stat ahead. And so we've introduced, in advance of metadata write-back caching, a batched RPC protocol change so that you can send multiple requests in one network message. And so, you can say get adder for 50 FIDs at a time, and then get all of the attributes back in a bulk transfer rather than 50 separate RPCs. And so that's more efficient from the network processing point of view, and you have lower latency. I mean, the individual RPCs are higher latency, but on the server side you have lower latency because you're not doing a network round trip each time. And so what we're going to use that for is the improved stat ahead. And so stat ahead is considered like metadata read ahead. So if you're doing a read dir and accessing the attributes of each file sequentially, we start to prefetch the attributes in advance of the application requesting them. And that's good for LS-L and things. And so we're improving that further, the stat ahead, so that we can do breadth first or depth first search. And so rather than just doing stat ahead in one directory, we can do cross-directory stat ahead. And that will, speculatively prefetch attributes in a whole directory tree if we detect that a pattern like that is being used by the application. And so that's good for find and other kind of, browser type applications that are, accessing a whole tree of files. And then that's the preliminary. So in 2.16, we're going to do the stat ahead part, and then in 2.17 we're going to be landing more of the write-back caching, and so that's allowing metadata operations to only happen directly on the client. And so what's happening there is in new directories, or speculatively on existing directories, you can get an exclusive lock on the directory, and then the client will have complete control of that hierarchy of the directory tree. And so this is good for workloads, let's say untar or something like that, where you create a lot of files on one client and then process it locally. And so that's useful for things like genomics and machine learning, where you untar a whole tree of files and then access a lot of the files quickly. And with the write-back cache, the client can create without the round trip to the MDS for every file. And it's in our testing, it's been about 10 times or 20 times faster for certain workloads. And it still remains coherent with regular file access, because we have a lock on the top directory. And so if a client tries to descend through that directory, it revokes one level of the lock, gets exclusive locks on the next level of directories, flushes out the top level cache, and then, if a client is working its way down one directory tree, we only have to flush the cache on the one directory tree. And there'll also be like a time-based, aging out of files and cache, or memory pressure-based aging out of files and cache. And so it's all consistent and shouldn't need significant or any modifications to applications. It's just the question is, picking appropriate heuristics on when to use this interface. And finally, this is a little bit speculative, quite a bit speculative, but trying to improve the redundancy and reliability of the MDS, because right now, MDT0 is doing a lot of important functions, but there isn't any redundancy. And so I've been looking at what we can do to incrementally improve the reliability of the metadata service without, having, I don't personally like having like a huge project where you don't get anything, for 2 years, right? Because, management priorities change or whatever. And so I've looked at, what we can do. And so the first phase would be trying to do, make some of the individual services that run on MDT0 more robust. For instance, the file FLDB, that's the FID location database. That's kind of the primary table that tells every client, FIDs in this range belong to MDT0, MDT1, et cetera, and each server, each MDT and OST has a partial copy of this data today, but only MDT0 has a full copy of it. And there's really no reason why all of the servers can't have a full copy. And then if one of them loses it, that you should be able to fetch this data from any other server, right? Same thing, like the quota tables are all managed by MDT0. There's no reason we couldn't hash out the quota across different metadata servers so that we, spread out the load. And some of the other project, the 1B that we're doing, improving the distributed transaction performance, that's something that we can, do independently of any big project, and it will help all kinds of D&E operations. Because the more D&E that we do with distributed transactions, the better, the performance has to be so that it doesn't impact you badly. And once those things are done, we can start doing the 1C project, which would be starting to do mirroring of top level, like a root directory, so that you can access, at least parts of the file system, even if MDT0 is offline, right? And because the root directory doesn't get modified very often, having a mirror copy of it wouldn't impact the performance too badly. But we would definitely need to do distributed transactions for every update to that directory. And so I think that's what I have today. Any questions?
Thank you.
Is there any work going on with metrics or monitoring of Lustre? That hasn't been mentioned so far.
Yes and no, right? I mean, we do, incrementally improve some of the statistics and things like that. One of the, smaller projects is, I don't know if you know job stats, right? And so to add in per job BRW stats, essentially, so that we get a histogram of the I/O patterns for each job at the server side. But I mean, the monitoring, the overall monitoring of Lustre is usually deferred to some third-party tools, right? And so each, vendor, and some people use Grafana or whatever, DDN has tools to do that, HPES has tools. And so we provide, from Lustre, we try to provide the useful information, and then how that gets displayed is up to somebody else.
Okay, thanks.
There's a question.
Yeah, it's me again. I just would like to add to that this field for job stats is a little bit short.
Sorry, I didn't.
The field for the job stats is a little bit short. I think it's 32 characters long or something like that.
Yeah, the job ID is, yes. So the question is the job ID is too short. And the unfortunate thing is, I mean, that's part of the network protocol, right? And so, for many people, 32 is okay. It's not perfect, but we would have to change the network protocol to increase that, and that's not super easy. And it would be, if we made it 128, that would be like 96 bytes of wasted space in every single RPC, and there's, tens of millions a second, so.
Could you get a flag to turn off that warning from the logs?
Oh,
because
yeah.
Once I know it's too long, I know why it's too long.
Okay, yeah, I mean, it's true, yes. I mean, yes, we could.
Uselessly.
I don't know if we fixed that, we might have fixed that, but if we didn't, please file a ticket so it doesn't get forgotten, and then we can make that like a one-shot error message or something like
Yeah,
that.
it's still there.
Yeah.
In the latest version I have. So.
Yeah, okay.
Okay, it's okay.
I have a
Cool.
question. For the metadata write-back cache,
Yeah.
is there any client or user command needed to hold the lock of the directory for this, or is it magic?
No, I mean, I believe if you create a new directory, it will initially get an exclusive lock, right? So it will be kind of eager on the directory creation, but as soon as if you do have like a parallel workload where you create a directory and then, all of the ranks create files or subdirectories or whatever, then you would have one extra RPC. But in also a common case where you create a directory and then the clients create files within that directory, you get the benefit of write-back caching. But there are going to be commands, LFS, WBC, pin and unpin and flush and all of these different things to manage the cache state. But it's intended that it can be done transparently, but there's interfaces if you know better, how it's going to work, right? And so initially, it's mostly going to work only for new directories, right? But there is the possibility to have the write-back caching work for existing directories. But what has to happen is the client would get the exclusive lock and then read in the full directory content for that directory so that it knows, which names can be created and which ones exist already. And so that's going to be in a later stage of development.
And what about the recovery in case of crash? Are the creation lost or?
Yeah, it's like any other crash if you haven't written it, right? But if you do fsync and things like that, then yes, they would flush and your fsync wouldn't return until it's written to disk, right? But it's true of any write-back data,
Andreas,
Yeah.
I wish to be a little bit controversial and just ask you one thing. I've seen your presentations now for the last 10 plus years.
Yeah.
And one of the things I seem to see a pattern of is that the number of new features are getting fewer and fewer every time we go to a major release. Is this because there's no good ideas left, or is it just being more and more complicated developing new features?
I think there's a few factors there. I mean, yes, the code is larger and more complicated. I think also, Lustre's getting very feature rich, and so we don't have, there isn't a burning need for, DOE labs to pay, for new features to be developed all the time, right? We can run on the biggest machines without, brand new features all the time, right? And so we used to have a dedicated, team of 20 people developing new features all the time, and so that's just not as important anymore. And reliability and things like that, polishing the corners and making all the commands easier to use has, taken over in terms of priority. So that's, those are not features that you write home about, but things like the MDT space balancing, right? It just works under the cover. You don't really see, much difference except that D&E 1 and 2, which took, 10 years to develop, it works now without a PhD.
Well, the reason I'm asking is that, I think everyone in this country lives, this room lives and breathes Lustre in one way or another. Unfortunately, I'm seeing some decisions from upper management in not just our company and others that keeps claiming that Lustre is running out of steam. We need to come up with something new. But that is not what you think in this case.
No. I mean, if you look at the performance numbers, right? I mean, some, competing products, right? They claim, it was engineered from the ground up for Flash and blah, 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 right? And we don't have the legacy, you know, encumbrance of disk storage. But if you look at, you know, QLC flash, it's really like a RAID device. I mean, it needs big aligned writes to get the best performance. You know, that's like RAID. And, you know, if you look at the performance per unit capacity, Lustre does way better than many of those competing products, even though they're, you know, engineered from the ground up. It's just that they're written badly and, you know, didn't, I mean, it's true with, I mean, I call it lazy programming today where, you know, you have this, you know, Python multi-layer framework and it doesn't, the developer resources are the expensive thing and the hardware resources are the inexpensive thing. And so the lazy programmer can get something done just by scaling it out to many nodes, and you don't have the focus on what, you know, making the most efficient usage of the individual components, right? And, you know, Lustre has grown up, you know, in the day when I/O was, you know, expensive and you optimized for it, right? And so I think we still have all of that benefit. And, you know, I presented in another presentation a few years ago the scaling of Lustre over time. And we've actually had a, you know, super linear scaling above the speed of the hardware, which is growing, you know, exponentially, whatever, 1.2 times a year. And Lustre performance has been growing at 1.3 times a year because we keep on making more and more efficient usage of the hardware over time. And so, you know, is Vim running out of steam, you know, or GCC or whatever, right? It's just because it's not getting tons of feature doesn't mean that it doesn't work. It's actually sort of better to consider that it's not getting, you know, tons of things crammed in Lustre 2.4. You know, if you see Peter Jones's slide and the number of lines of code that went into that release, right? And granted, you know, ZFS and D&E both went in at the same time, but that led to, you know, a lot of hardship in terms of stability, right? So we're still seeing, you know, interesting features going into Lustre. It's just not as high a priority as it used to be.
Thank you.